Research is hard, but your tools should not be. Subthesis.com is the free alternative to expensive software. Whether you need to calculate Cronbach's alpha or organize your field notes, Subthesis has a tool for it. No paywalls and no registration required. Check the link in the description and let's dive into today's lesson. Welcome to our final video in Section E on Research Readiness, where we explore Introduction to Data Analysis. You've developed your research question, designed your study, and collected your data. Now comes the moment of truth, making sense of what you've gathered. Data analysis is where raw information transforms into meaningful understanding. It's where the answer to your research question begins to emerge from the evidence you've collected. This transformation doesn't happen automatically. It requires systematic procedures, appropriate techniques, and interpretive skill. For many graduate students, data analysis feels intimidating. Quantitative analysis involves statistical procedures that seem mysterious. Qualitative analysis involves interpretive moves that seem subjective. Both traditions have developed rigorous approaches that can be learned, but understanding the fundamentals is essential before diving into specific techniques. Over the next 20 minutes, we'll explore principles that apply across analytical approaches. We'll cover data preparation, the often neglected work that precedes analysis itself. We'll introduce core analytical logic for both quantitative and qualitative traditions. We'll discuss interpretation, moving from analytical results to meaningful conclusions. And we'll touch on presenting findings effectively. This isn't a comprehensive methods course that requires extensive additional study, but it provides foundational understanding that will help you engage with more advanced training and make informed decisions about your own analytical approach. Before exploring specific techniques, let's consider the mindset that characterizes good data analysis. Analysis is systematic inquiry, not just calculation or coding. You're not simply running procedures and reporting outputs. You're investigating your research question using data as evidence. Every analytical choice should serve your inquiry's purpose. Stay open to what your data actually reveals, not just what you hope to find. Confirmation bias, seeing what you expect, threatens all research. The best analysts remain genuinely curious about what's there, following evidence wherever it leads, even when it contradicts expectations or complicates your story. Rigorous procedures combine with interpretive judgment. Analysis involves both following established techniques and making judgment calls about how to apply them. Pure mechanical application without judgment produces meaningless results. Pure intuition without rigor produces unreliable claims. Integration of both characterizes skilled analysis. Iterate between parts and whole. In quantitative work, this means moving between individual variables and overall patterns, between specific tests and the broader analytical strategy. In qualitative work, this means moving between individual segments and overall themes, between coded excerpts and integrated interpretation. The whole illuminates parts. Parts constitute the whole. Maintain ethical responsibility in how you represent your data. Analysis involves countless decisions about what to include, emphasize, and interpret. These decisions shape what readers understand. Accurate, honest representation, not distortion in service of desired conclusions, is a fundamental analytical obligation. Data preparation is the essential but often underestimated work that must precede analysis. Raw data collected from the field is rarely ready for immediate analysis. Raw data contains errors, typos in survey responses, transcription mistakes, recording problems, coding inconsistencies. It may have missing values requiring decisions about how to handle them. It may need restructuring to match analytical requirements. Preparation addresses these issues systematically. Cleaning involves identifying and addressing data quality problems. Are there impossible values, ages of negative numbers, or response codes outside valid ranges? Are there implausible responses, survey completion times of 3 seconds? Are there inconsistencies, the same participant identified differently in different records? Cleaning doesn't mean changing data to match expectations. It means identifying genuine errors and handling them appropriately. Organization structures data for your intended analysis. Quantitative data may need variable creation, recoding, or reshaping between wide and long formats. Qualitative data may need organizing into analytical units, cases, segments, documents that enable systematic comparison. How data is organized affects what analysis is possible. Documentation throughout preparation creates the audit trail supporting transparency. What cleaning decisions did you make? What values were changed and why? What organizational transformations occurred? Documentation enables others to understand and evaluate your preparation and allows you to retrace steps if questions arise. Preparation often takes more time than analysis itself. Budget for this reality in your timeline rather than assuming you can proceed directly from collection to results. Quantitative data preparation involves specific procedures that precede statistical analysis. Create and code variables appropriately. Raw survey responses may need reverse coding for consistent direction. Multiple items may need combining into scale scores. Continuous variables may need categorization for certain analyses. Ensure variable coding matches your planned analyses. Assess and address missing data systematically. How much data is missing? Is missingness random or systematic? Complete case analysis deletes any case with missing data, but may bias results if missingness isn't random. Imputation techniques estimate missing values based on available data, but involve assumptions. Choose handling approaches deliberately based on your data's characteristics. Identify and handle outliers, extreme values that differ markedly from other observations. Are outliers data errors requiring correction, legitimate extreme cases requiring retention, or influential observations that distort results? Different contexts warrant different responses. Document your decisions regardless of approach. Check statistical assumptions relevant to your planned analyses. Normality, homogeneity of variance, linearity, independence. Different tests assume different conditions. Violating assumptions can produce unreliable results. Assessment methods include visual inspection, statistical tests, and rules of thumb for robustness. Know what your planned analyses assume. Document all preparation decisions thoroughly. Create a data dictionary defining every variable. Record all cleaning and recoding. Save original data separately from analysis-ready datasets. Complete documentation enables replication and protects against accusations of data manipulation. Qualitative data preparation involves different activities than quantitative preparation but is equally essential. Transcription of audio and video recordings creates text that can be systematically analyzed. Verbatim transcription captures exact words. Naturalized transcription includes hesitations, overlapping speech, and nonverbal elements. The appropriate level of detail depends on your analytical approach. Transcription is time-consuming. A 1-hour interview typically requires 4 to 6 hours to transcribe, so budget accordingly. Familiarization through repeated engagement with your data builds the intimate knowledge that enables good analysis. Read transcripts multiple times. Listen to recordings while reading. Immerse yourself in the material before beginning formal coding. This familiarity helps you recognize patterns and nuances that superficial engagement would miss. Organize data into analytical units appropriate for your approach. In case study research, organize by case. In thematic analysis, organize by data source or participant. In grounded theory, create segments for constant comparison. How you structure data affects analytical possibilities. Initial holistic reading before coding provides overview understanding. Before breaking data into coded segments, understand each piece as a whole. What's the overall story? What stands out? What patterns are emerging? This big picture view informs and contextualizes subsequent detailed coding. Early memoing captures emerging ideas, questions, and analytical thoughts. Write memos from your first engagement with data, reflections, hunches, possible interpretations, connections you're noticing. These early memos often contain seeds of eventual findings and create records of your developing analysis. Quantitative analysis encompasses a vast array of techniques, but understanding the basic landscape helps you navigate toward appropriate methods for your questions. Descriptive statistics summarize what's in your data without making broader claims. Measures of central tendency, mean, median, mode, describe typical values. Measures of variability, standard deviation, range, interquartile range, describe spread. Frequencies and percentages describe distributions. Descriptive statistics are essential for understanding your data and reporting sample characteristics. Inferential statistics use sample data to draw conclusions about larger populations. Because samples inevitably differ from populations through sampling error, inferential statistics estimate how confident we can be that sample patterns reflect population patterns. P-values, confidence intervals, and effect sizes all address this inferential challenge. Relationship testing examines associations between variables. Correlation quantifies the strength and direction of relationships. Regression predicts one variable from others and enables control for confounding variables. These techniques address questions about whether and how variables relate. Group comparison tests examine differences between groups. T-tests compare two groups. ANOVA compares multiple groups. These techniques address questions about whether groups differ on outcomes of interest. Experimental research frequently uses these approaches. Advanced methods address more complex research questions. Multi-level modeling handles nested data. Structural equation modeling tests complex theoretical models. Longitudinal techniques analyze change over time. These require substantial additional training but become relevant as research questions grow sophisticated. Selecting appropriate statistical tests depends on several factors. Understanding these helps you choose well. Variable types fundamentally constrain test options. Categorical variables, nominal or ordinal, require different tests than continuous variables. Chi-square tests work with categorical variables. T-tests and ANOVA work with continuous dependent variables and categorical independent variables. Correlation and regression work with continuous variables. Know your variables, measurement levels. The number of groups or variables affects test selection. Comparing two groups, T-test. Comparing multiple groups, ANOVA. Examining one predictor, simple regression. Examining multiple predictors, multiple regression. Tests are designed for specific configurations. Your research question should guide test selection, not the other way around. Are you asking about differences, relationships, or predictions? Are you describing associations or testing causation? Match techniques to questions rather than using familiar tests regardless of fit. Verify that your data meet test assumptions before proceeding. Violating assumptions may require alternative tests, non-parametric alternatives for non-normal data, robust methods for heterogeneous variances. Running tests despite violated assumptions produces unreliable results. Consult methodological resources when uncertain. Statistics textbooks, methodology consultants, and statistical software documentation provide guidance for test selection. Don't guess, find authoritative guidance for your specific situation. Incorrect test selection undermines the validity of your findings. Qualitative analysis transforms textual or visual data into meaningful understanding through systematic but flexible procedures. Different qualitative approaches have distinct procedures, but common elements appear across many traditions. Coding involves labeling segments of data with terms that capture their content or meaning. Initial codes may be descriptive, simply naming what's there. Later coding becomes more analytical, interpreting what data means. Codes create a systematic way to organize and retrieve data on specific topics. Theme development identifies patterns that recur across your data. Themes are more than topics. They capture something meaningful about the phenomenon you're studying. Good themes are grounded in data, capture something important, and work coherently with other themes to tell your analytical story. Interpretation makes meaning of the patterns you've identified. What do these themes tell us? How do they relate to each other? What do they suggest about your research question? Interpretation moves beyond description to analytical claims about what you found. Constant comparison, checking your developing analysis against data, ensures that interpretations remain grounded. As themes develop, return to data to verify they fit. Seek disconfirming evidence that might challenge your interpretations. This discipline distinguishes rigorous qualitative analysis from impression-based conclusions. Integration builds coherent understanding from the parts of your analysis. Individual themes combine into an overall narrative or framework. The final product should feel like more than a list of findings. It should offer integrated understanding of your phenomenon. Coding is often misunderstood as simple labeling. Actually, it's a sophisticated analytical activity that evolves through stages. Initial or open coding stays close to the data, generating many codes that capture what's present in the text. At this stage, you might code almost every line or small segment. Don't worry about having too many codes or codes that overlap. This stage is about opening up the data to see what's there. Focus coding selects and refines the most significant or frequent initial codes for more intensive analysis. Not every initial code proves analytically important. Focus coding concentrates attention on codes that best capture what's happening in your data and relate to your research question. Axial coding, in grounded theory traditions, explores relationships between categories. How do categories connect? What are the conditions, contexts, and consequences that relate them? This stage builds structure beyond simple thematic lists. Theoretical coding integrates your analysis at higher levels of abstraction. How do all your categories and themes fit together? What's the core story or process your analysis reveals? Theoretical coding produces the conceptual framework that becomes your contribution. In vivo codes use participants' exact words as code names. When participants use particularly vivid or apt phrasing, preserve it. In vivo codes keep analysis grounded in participants' perspectives and often produce compelling language for reporting findings. Different qualitative approaches emphasize different coding procedures, but most involve some progression from concrete description toward abstract interpretation. Analytical software is essential for most contemporary research, but it's important to understand its role properly. Software facilitates analysis but doesn't replace analytical thinking. Statistical software doesn't know which tests are appropriate or what results mean. Qualitative software doesn't generate themes or interpret their significance. You make the analytical decisions. Software implements them efficiently. For quantitative analysis, common packages include SPSS, which is widely used in social sciences with point-and-click and syntax options, R, which is free, powerful, and increasingly popular but has a steeper learning curve, Stata, which is strong for econometric and panel data analysis, and SAS, which is common in healthcare and large-scale survey research. For qualitative analysis, options include NVivo, a comprehensive package widely used in academic research, Atlas.ti, with strong visual tools and team collaboration features, Deduce, a cloud-based option accessible from anywhere, and MaxQDia, which has strong mixed methods capabilities. Learn one tool well rather than attempting superficial familiarity with several. Deep knowledge of one package enables efficient, sophisticated analysis. Most software can do most things. Expertise in your chosen tool matters more than which tool you choose. Check what's available through your institution. Most universities provide licenses for major statistical and qualitative packages. Free options like R and some qualitative tools are also viable. Don't spend personal money before investigating institutional resources. Rigorous analysis, whether quantitative or qualitative, requires disciplined practices that protect against error and bias. Follow systematic procedures consistently throughout your analysis. If you're running statistical tests, follow established protocols for each test type. If you're coding qualitative data, apply codes consistently across all material. Ad hoc, inconsistent procedures produce unreliable results. Document decisions and their rationale throughout analysis. Why did you exclude certain observations? Why did you combine these codes into a theme? What alternatives did you consider? Documentation creates the audit trail that enables others to evaluate your work and allows you to reconstruct your own reasoning. Verify results through checking. In quantitative work, this might mean running analyses multiple ways to confirm findings, having someone check your code, or examining results for plausibility. In qualitative work, this might mean returning to data to verify that interpretations are grounded, having colleagues review your coding, or seeking member checking from participants. Consider alternative explanations for your findings. What else could explain these patterns? Are there confounding variables you haven't considered? Could your interpretations reflect your assumptions rather than participants' perspectives? Actively seeking alternatives guards against confirmation bias. Maintain transparency about your analytical process. Your methods section should describe what you actually did, not an idealized version. Acknowledge challenges, limitations, and judgment calls. Transparency builds credibility and enables appropriate evaluation. Interpretation bridges analytical results and meaningful conclusions. Good interpretation follows principles that produce defensible claims, ground interpretation in evidence. Every interpretive claim should connect to specific data. In quantitative work, statistical results provide evidence. In qualitative work, quoted material and described patterns provide evidence. Interpretation untethered from evidence becomes speculation. Make claims appropriate to your methods. Correlational studies support claims about association, not causation. Qualitative studies support claims about meaning and experience in studied contexts, not prevalence in populations. Know what your methodology can establish and don't overclaim. Consider context and limitations when interpreting. Your findings emerge from particular participants, settings, times, and conditions. How might different contexts produce different findings? What boundaries should readers understand around your claims? Contextualizing interpretation demonstrates sophistication. Connect to theory and prior research. Your findings don't stand alone, they join ongoing conversations. Do your results support or challenge existing theory? How do they compare to prior findings? Interpretation should situate new findings within existing knowledge. Acknowledge uncertainty appropriately. Not all findings are equally robust. Some patterns are clear, others are tentative. Some interpretations are strongly supported, others are plausible but less certain. Communicating appropriate degrees of confidence respects readers' need to evaluate claims. Awareness of common pitfalls helps you avoid them in your own analysis. Confirmation bias leads you to see patterns that match your expectations while missing those that don't. You may interpret ambiguous data as supporting your hypothesis without considering alternatives. Combat this by actively seeking disconfirming evidence and having others review your analysis. Overclaiming asserts more than your evidence supports. Qualitative studies that claim findings generalize to populations, correlational studies that imply causation, or any study that overstates certainty all overclaim. Carefully match claims to what methods can establish. Cherry-picking selectively presents data that supports your conclusions while ignoring data that doesn't. In quantitative work, this might mean reporting only significant findings. In qualitative work, this might mean quoting only supportive examples. Honest analysis represents the full picture, including complications. Ignoring contradictions dismisses data that challenges your interpretations. Every dataset contains some contradictory elements. Rather than hiding these, acknowledge and engage them. What explains contradictions? Do they reveal limitations of your interpretation? Premature closure stops analysis before patterns fully emerge. The pressure to finish pushes toward ending analysis too quickly, but stopping before reaching saturation in qualitative work or without examining all relevant relationships in quantitative work produces incomplete findings. Resist pressure to shortcut thorough analysis. In quantitative work, p-hacking, running many tests until something reaches significance, produces spurious findings. Pre-register analyses. Adjust for multiple comparisons and distinguish confirmatory from exploratory analyses. Mixed methods research requires analyzing both quantitative and qualitative data, then integrating findings in ways that add value beyond what either approach provides alone. Analyze each strand using methods appropriate to that data type. Quantitative data receives statistical analysis. Qualitative data receives thematic or other appropriate qualitative analysis. Don't try to force one type of data into the other's analytical framework. Integration is what distinguishes true mixed methods from parallel separate studies. Simply conducting quantitative and qualitative analyses without bringing them together doesn't realize mixed methods' potential. The real value comes from synthesis. Compare findings across methods. Do quantitative patterns match qualitative themes? Does statistical data confirm or complicate what participants describe in interviews? Convergence, when both methods point the same direction, strengthens confidence. Divergence, when methods produce different pictures, requires explanation and often reveals important complexity. Address both convergence and divergence explicitly. Don't just report matching findings while ignoring contradictions. Divergent findings often produce the most interesting insights as you work to understand why different methods produce different results. Generate insights beyond what either method alone could produce. Mixed methods should answer questions neither quantitative nor qualitative approaches could adequately address independently. If your integrated findings simply restate what each method found separately, integration hasn't achieved its purpose. Presenting quantitative results effectively requires strategic choices about what to include and how to display it. Tables work best for presenting precise statistical values, means, standard deviations, test statistics, p-values, effect sizes. Well-designed tables organize information efficiently, allowing readers to find specific values. Keep tables focused rather than overwhelming readers with everything you calculated. Figures work best for showing patterns and relationships. Visualizing distributions, trends over time, or relationships between variables can communicate more effectively than tables of numbers. Choose visualization types appropriate to your data and message. Bar charts, line graphs, scatter plots, and others serve different purposes. Narrative should interpret what results mean, not just repeat what tables and figures show. Don't write, as shown in Table 1, the mean was 3.4. Instead, explain what the mean of 3.4 tells us about your research question. Help readers understand significance, not just statistical significance. Follow disciplinary reporting standards. APA style specifies how to report many statistical tests. Other disciplines have their own conventions. Know what your field expects and follow those standards consistently. Make results accessible to your intended audience. Technical readers may want detailed statistical information. General audiences may need more explanation and less technical detail. Consider who will read your work and present accordingly. Never report statistics you don't understand. If you can't explain what a result means, you shouldn't include it. Presenting qualitative findings effectively requires different strategies than quantitative results, but equal attention to clarity and persuasion. Organize findings around themes rather than data sources or individual participants. A finding section that says, Participant 1 said X, Participant 2 said Y, Participant 3 said Z doesn't synthesize. Instead, present themes with supporting evidence from multiple participants. This demonstrates pattern and integration. Use rich quotations as evidence for your interpretive claims. Quotations bring participants' voices directly into your text and show readers the data underlying your interpretations. Select quotations that are vivid, representative, and clearly illustrate the point you're making. Cite more quotations than you need, then select the best ones. Balance participant voice with interpretive commentary. Raw quotations without interpretation leave readers to draw their own conclusions. But so much interpretation that quotations become rare removes evidence for your claims. Find the balance that shows both data and analysis. Consider visual representations of themes. Diagrams, models, and figures can capture relationships between themes that narrative alone struggles to convey. If your findings involve a process, sequence, or structure, visual representation may communicate more effectively than text alone. Build a coherent narrative from your findings. Individual themes should connect to tell an integrated story. Readers should understand not just what each theme is, but how themes relate and what the overall finding means. Your findings section should feel like more than a list. Analysis often presents challenges beyond what individual researchers can handle alone. Knowing where to find support makes the difference between stuck and successful. Your advisor provides guidance on overall analytical approach. They should help you choose appropriate methods, review your analytical plan, and provide feedback on your interpretations. Regular meetings during analysis keep you on track and catch problems early. Don't disappear into analysis for months without check-ins. Statistical or methodological consultants offer specialized expertise your advisor may lack. Many universities maintain consulting services for complex statistical questions. Methodological experts can advise on qualitative approaches. Don't struggle with analytical challenges when expert help is available. Consulting isn't cheating, it's wisdom. Peer collaboration provides valuable perspective. Colleagues who understand your research can review your coding, check your statistical work, and respond to your interpretations. Teaching others about your analysis clarifies your own thinking. Study groups, writing circles, and informal collaboration all contribute. Workshops and continuing education address skill gaps. If your analysis requires techniques you haven't learned, seek training. Methods workshops, software training sessions, and online courses can build needed capabilities. Investing in skill development pays dividends throughout your career. Online tutorials and communities offer just-in-time learning. YouTube videos, Stack Exchange discussions, and methodology forums can answer specific questions when they arise. The online methods community is vast and often helpful, though quality varies, so evaluate sources critically. Analysis produces findings, but findings must connect to broader implications to fulfill research's purpose. Different types of implications matter for different audiences. Theoretical implications connect your findings to explanatory frameworks. Do your results support existing theory, challenge it, or extend it to new contexts? How do your findings advance theoretical understanding of your phenomenon? Even applied research usually has theoretical implications worth articulating. Practical implications translate findings into guidance for practitioners. If you studied teaching strategies, what should teachers do differently based on your findings? If you studied organizational practices, how should managers apply your results? Making practical implications concrete helps bridge research and practice. Policy implications identify relevance for policymakers. What do your findings suggest about current policies? What policy changes might your results support? Policy implications require appropriate humility. Single studies rarely dictate policy, but identifying policy relevance expands your research's potential impact. Future research directions identify questions your study raises but cannot answer. Every study has limitations that suggest further investigation. What would you do differently? What emerged that deserves its own study? What remains unknown even after your research? Future directions demonstrate awareness of your study's place in ongoing inquiry. Connecting specific findings to broader significance requires stepping back from analytical details. What's the so what of your research? Why should anyone outside your narrow specialty care? This big picture thinking transforms findings into contribution. Let's apply what we've covered by planning your analytical approach. Even if you're not yet at the analysis stage, thinking through these questions builds analytical awareness. First, what questions will your analysis address? List your research question and any sub-questions. Each analytical procedure should connect to answering these questions. If you can't articulate what question an analysis addresses, reconsider whether it's necessary. Second, what analytical approaches are appropriate for your questions and data? Given what you now know about different approaches, which fit your situation, are there multiple appropriate options you need to decide between? What criteria will guide your choice? Third, what skills do you need to develop before analysis? Be honest about gaps between required techniques and your current abilities. What training do you need? What resources will help you learn? How will you build necessary competence before analysis begins? Fourth, what software and resources will you use? Which statistical or qualitative analysis software? What documentation and tutorials? What consultation resources might you need? Planning your analytical infrastructure in advance enables smoother implementation. Fifth, what is your realistic timeline for analysis? Given your data volume, complexity, and analytical approach, how long will analysis take? Build in time for learning, iteration, and unexpected challenges. Rushed analysis produces weak findings. Let's consolidate what we've covered in this introduction to data analysis. Data preparation, cleaning, organizing, and documenting precedes meaningful analysis. Raw data requires substantial work before analysis can proceed. Budget time for this essential phase and maintain documentation throughout. Match your analytical approaches to your research questions and data types. Different questions require different methods. Quantitative questions need statistical approaches. Qualitative questions need interpretive approaches. The question leads, the method follows. Rigor in analysis requires systematic procedures and thorough documentation. Whether quantitative or qualitative, disciplined practices protect against error and bias. Consistency, verification, and transparency characterize trustworthy analysis. Interpretation bridges analytical results and meaningful conclusions. Good interpretation remains grounded in evidence, makes appropriate claims, considers context and limitations, and connects to broader theory and prior research. Interpretation transforms findings into contribution. Congratulations, you've completed Section E on research readiness. You now have foundational understanding of developing research questions, reviewing literature, selecting methodology, navigating ethics review, collecting data, and analyzing what you've gathered. These foundations prepare you for the actual research you'll conduct. In our final section, Section F on professional development, we'll explore building your professional identity beyond the dissertation, networking, job markets, publishing, presenting, and planning your post-graduation career. The skills you've developed position you for these professional challenges ahead. Writing the thesis is a marathon, not a sprint, but you do not have to run it alone. If you are feeling stuck with your data or overwhelmed by your sources, let us help. Head over to subthesis.com. It is completely free and designed to make your life easier. You are making progress. Keep going. And don't forget to subscribe for more support.